Following on from metabolic pathways, this time we'll look a little closer at enzymes. So each of the different reactions in the metabolic pathway is controlled or catalyzed by a particular enzyme. Okay? So we need these enzymes for the reactions to proceed. Okay? So the important features of the enzyme are its active site, which is going to have a complementary shape to the substrate. The substance is either going to break down or build up. So the substrate will bind to the active site, and this is where the chemical reactions take place. So really important, it's molecules needed to control all of these different reactions taking place inside of the cell. So the presence of enzymes are what actually allow the reaction to complete. So as we increase our enzyme concentration, we increase our rate of reaction or how quickly we get to our end product. We also know that if there's ever an absence or a loss of a particular enzyme, that can have a negative impact on these pathways. So that if we knocked out enzyme A, for example, that means substrate 1 isn't going to be converted into substrate 2, which means there's no 2 to make 3 or 4, and we don't get to our end product. So their presence or absence are really important in allowing these metabolic pathways to proceed. So how do these enzymes allow these reactions to happen and happen at temperatures suitable to the human cell? Well, what they do is when the substances bind into their active sites, this actually reduces the activation energy or the amount of energy that needs to be supplied in order to let the reaction take place in the first instance. So we need to supply some energy to convert our reactants to products, but because the reaction itself is taking place within the active site, this reduces or decreases the amount of energy that's required to do the reaction. So without enzymes, we would not be able to do these reactions quickly enough to sustain all of the cellular functions. So other ways that enzymes can ensure these reactions proceed and proceed efficiently is by doing something known as induced fit. So we've got our complementary shaped substrate binding into the enzyme's active site, but what the enzyme can do is slightly adapt, slightly change its shape better to fit the substrate, hold on to that a little bit more tightly, and then that allows the reaction to proceed even more effectively than before. So it works so well because enzymes have a high affinity for their substrates. So there's a good, strong chemical attraction between the active site and the substrate that is to be catalysed during this reaction. So that pulls the substrate into the active site and allows the reaction to take place. But at the end of the chemical reaction, we have products. These products have a low affinity or low chemical attraction to the active site, and that's what then allows them to leave at the end of the reaction. So we've got our substrates, what we start with, the products, what we make. These are also important for controlling the rate of reactions, and particularly in these reversible pathways about which direction the reaction actually proceeds in. Okay? So with these reversible reactions, how does the cell decide whether it's going to do the forward or the backward reaction? Now that's always going to come back to the concentrations of your substrates and of your products. So if C and D are in low supply, for example, then that's going to drive the forward reaction. So the absence of the products means we want to produce more of them. However, if they were in high concentration, then that would drive the backward reaction. We don't want C and D to build up to toxic levels, so we would convert them back into A and B to make sure they were in plentiful supply. So cells need good supply of the substrates and wants to control the concentration or the amount of product that is produced. So thinking about enzyme control of these reactions, try a past paper question. So the graph below shows the changes to the concentrations of substrate and product during an enzyme-controlled reaction. So which line in the table below identifies the substrate, the product, and the change in the rate of reaction during the process? Okay, pause the video, select your answer, hit play when you're ready to find out which line is correct. So the correct answer here is D. So let's look back at the graph. So we've identified Y as our substrate, okay, and that makes sense. We think from the start to the end of the reaction, Y is going to be converted into its product, so we would expect the substrate concentration to decrease as the reaction continues, okay? Which means X must be the product, and again, makes sense because X is what we're making during the reaction, so we would expect its concentration to increase the more we do the reaction. Okay? But as for the rate of reaction, how quickly it's proceeding, how effectively we're getting to our end product, well, over time this is going to decrease because we're using up our substrate. If we don't have our substrate, the reaction cannot continue. That's why you've always got to ensure there's a plentiful supply of your substrate. So I hope this has helped you understand enzyme action a little bit more. And in the next one, we'll look at some of the factors that might interfere with the enzyme and its reactions.